darkness. Not the darkness of night, but a darkness without contrast. A darkness that no longer remembers what light once meant. Across this abyss, a single photon drifts. Its wavelength stretched beyond comprehension, its energy thinned to almost nothing. Its origin lost in an age when stars still breathed fire. This is not a beginning. This is a remnant. This is the last light. Time accelerates, billions of years passing like moments. Galaxies withdraw from one another, their outlines dissolving, their ancient arms shredded by the expansion of space. The cosmic background cools, its once fiery glow now a faint whisper, its temperature sliding toward absolute zero. The film slows. The sound drops away. Only the silence of expansion remains. This is the far future predicted by thermodynamics. Every process moves toward greater entropy, every system toward equilibrium, and the universe is no exception. Heat death, the ultimate winter, has stalked our equations for more than a century. It is not a violent apocalypse, but a slow unfurling of nothingness. A cosmic ice age in which no spark survives unspent. Mini reveal. Even nothingness has a structure. Space itself swells. It's not empty, but thick with dark energy. A pressure that drives galaxies apart faster than gravity can reunite them. The cosmological constant, once a footnote in Einstein's work, has become the ruler of the future. Dark energy is the wind of this great retreat, blowing matter into irrelevance. Stars fade, their cores exhausted, their light cooling into infrared embers, then radio ghosts. White dwarfs crystallize into black dwarfs crumble into dark. Protons themselves, once thought eternal, may decay over unimaginable eons, leaving only photons, leptons, and the endless curvature of space. What began as brilliance ends as near nothing. Short beat. The camera glides through this emptiness. No planets, no orbits, no night sky, for there is no sky at all. Longer drift. In the absence of stars, time itself loses meaning. Each second stretches as expansion accelerates. Clocks running slower relative to one another, distances swelling until causal contact is severed. Islands of matter become solitary universes, cut off, invisible, self-contained. Each island drifts alone into the dark sea of the void. Thermodynamics and cosmology converge here. Entropy measures disorder, but also measures possibility. As entropy approaches its maximum, the universe becomes more uniform, less able to do work. Heat death is not coldness alone, but sameness, a flattening of contrast. Without gradients, no motion. Without motion, no story. Yet even here, quantum fields do not sleep. In the emptiness, virtual particles flicker and vanish, borrowing energy from nothing, returning it almost instantly. This quantum foam is the universe's last murmur, a restless substrate beneath stillness. It suggests that nothingness may not be truly nothing. The void is pregnant with possibility, a stage that could, under unknown conditions, birth a new act. Mini reveal. Some theories hint the vacuum we inhabit is not the true vacuum. If a lower energy state exists, the universe could tunnel to it, triggering a phase change across space. This is called false vacuum decay. In such a scenario, the universe as we know it could end in an instant. Not with a bang or a whimper, but with a new physics rewriting the stage. But here, in this chapter's frame, we are far beyond that point. No catastrophic transition has come. Only silence, only distance. Our photon continues drifting, its wavelength stretched to the size of galaxies. Its energy too low to ever be captured again. Slow passage. The narration floats over an infinite plane of emptiness, describing not shapes, but the lack of shapes, not colors, but their fading echoes. There is a beauty here, a purity in the absence of distraction. The void is not chaos, but a smooth, perfectly ordered desert. A cosmic horizon has swallowed all familiar landmarks, and still, questions burn. Does entropy have an endpoint, or is it asymptotic, forever approaching but never arriving? Does dark energy remain constant, or could it evolve, reverse, or intensify into a final rupture, a big rip shredding even the fabric of space? These are not just scientific questions. They are existential thresholds, echoing our own uncertainties about endings. Short beat. Camera pans outward. A grain of light lost in an ocean. Longer drift. The universe begins to resemble a mind closing its eyes, a thought dissolving at the edge of waking. But perhaps this is an illusion. Perhaps the void is not the end, but the waiting room for the next cosmic birth. The cycle could be hidden beyond our comprehension, seated in fluctuations too subtle for any equation to catch. Even in the deepest dark, symmetry can break. Even in the flattest field, a ripple can grow. In quantum cosmology, this is how worlds begin. A small instability, a new inflation, a new universe. The void is not a tomb, but a chrysalis. The narration slows again. We return to our photon. It has no destination, only trajectory. Its existence a testament to what once was. Its persistence a question about what may still come. Science gives numbers for this darkness. 10,100 years for star death. 1044 proton decay. 10 trillions for black holes evaporating. Yet the human mind falters before such scales. We are built to measure heartbeats, not eons. And so the film lingers not on numbers but on feelings. Isolation, vastness, the soft hum of time, final movement. We pull back further, further still, until the lone photon disappears. There is no longer an object, no longer a frame, only a field of nearly perfect nothing, a black so deep it bends perception, silence that swallows narration itself. And in that silence, something stirs. Not light, not sound. A possibility. If the universe becomes a perfect void, is it truly an end, or the invisible skin of another beginning? The question lingers unanswered as the screen fades to black. The camera opens on a desk lit by a single lamp. Ink smears on parchment. mathematical symbols cascading like constellations across a night sky of paper. A hand pauses, trembling slightly, before inscribing a final symbol, a constant, an unknown. An answer to a question the world has not yet dared to ask. Long before the first star dies, the human mind dreams of the universe's ending. This instinct to trace boundaries follows us from the edges of ancient maps to the outermost horizon of space-time. We are cartographers of nothing, drawing lines around the invisible, naming what we cannot touch in the early 20th century. A young patent clerk turned physicist writes equations that overturn centuries of celestial certainty. Einstein's general relativity bends space and time, transforming gravity into the shape of geometry. But his equations predict something unnerving, a universe that cannot stand still. Either it expands or it contracts. Neither option fits the eternal cosmos most believed in. So Einstein inserts a balancing term, the cosmological constant, a quiet counterforce built into the fabric of space itself. It keeps the universe static, or so he hopes. This constant is the first sketch of a force that would one day be called dark energy, clue to a future where space itself rules over matter. The narration slows. Frames dissolve into black and white footage of the 1920s sky surveys. Telescopes made of brass and glass, eyes turn to a vault of stars. Edwin Hubble measures distant nebulae, discovering their entire galaxies receding from us at astonishing speeds. The cosmos is not static at all. It is rushing outward, its edges carrying the promise of infinity. As expansion becomes undeniable, cosmologists return to thermodynamics. If the universe grows colder and more diffuse, entropy will climb, and the stars will one day go out. Heat death, first whispered in the 19th century, comes back as a cosmic prophecy. The equations, no matter how they are bent, guide toward a future of thinning light, cut to chalk dust swirling in a lecture hall. Mid-20th century theorists debate competing fates: Big Crunch, a steady state, or eternal expansion into darkness. Each possibility redraws the map of time itself. Some see cycles, universes born and reborn. Others see a one-way corridor to nothingness. Each model a different portrait of the void. Each calculation a glimpse of the unfathomable. The cost of thinking about endings shows in their eyes. Students emerge from seminars silent, hands buried in pockets, staring at the ground as if at some distant horizon. Physicists write equations that feel like epitaphs, yet they cannot stop. There is something magnetic in the mystery of finality. To confront the void is to confront ourselves. Years pass. Technology sharpens. Satellites measure the faint afterglow of the Big Bang, detecting irregularities smaller than a millionth of a degree. The cosmic microwave background becomes a map of both the past and the future. In this map hides a signature not of matter, but of something deeper, a hidden pressure, a tension within space itself. By the late 20th century, astronomers expect gravity to slow cosmic expansion. They chart galaxies, measure redshifts, calculate the universe's deceleration. But the data defy their models. Instead of slowing, the expansion accelerates. Space is stretching faster and faster, like a breath it cannot hold. This discovery lands like a tremor across the field. Dark energy, a name for our ignorance, yet also a real force outpacing all else. The cosmological constant, once Einstein's embarrassment, returns as a ruling principle. Space itself wins. Matter becomes a temporary texture woven into an ever-growing void. The narration glides over simulation. Imagery, galaxies scattering like embers, clusters thinning into mist, eventually dissolving into the black. Astronomers trace lines on these simulations, projecting billions of years forward. Every path leads to the same conclusion, a future dominated not by stars, but by emptiness. Not by gravity, but by vacuum energy. Some call it vacuum energy. Some call it quintessence. Some imagine fields that change over time. Yet all versions share one vision: space infused with a subtle energy stronger than the pull of any galaxy. The void is not absence, but substance. A quiet ocean whose tides erase the coastlines of matter. The film slows to archival footage of Roger Penrose sketching space-time diagrams, lines converging toward singularities, surfaces pinched and folded, arrows pointing to the end of time. The math is clean, almost beautiful, but its implication is harsh. The future may belong not to stars or civilizations, but to the geometry of nothing. Yet there is a strange grace in this revelation. To discover that emptiness governs the future is to glimpse a larger canvas than we ever imagined. Our galaxies, our clusters, even our cosmic web, are filigree in a painting whose dominant color is black. The void is the frame, and everything else a temporary brushstroke in the control rooms of observatories. Scientists watch real-time plots of supernova, their light curves spelling out the universe's acceleration. No one cheers. The room is quiet. It feels like confirmation of a prophecy no one wanted to believe. As the chapter draws to its close, the narration returns to the desk from the opening shot. The lamp still burns. Papers still scattered. Equations still alive with symbols for infinity. The cartographers of nothing have traced their maps into regions no human will ever see. And yet those maps guide us all. They began by searching for balance, a force to hold the universe steady. They ended by discovering its future surrender, space stretching beyond all reckoning. The void is no longer a hypothetical absence. It is a destiny written into the equations themselves. Their work leaves a quiet echo, if nothingness is inevitable. What new truths might it contain? The map is drawn, but the territory still waiting, still expanding, still dark. The frame opens on blackness. But as the view deepens, the darkness trembles. Not empty, but alive. Space shivers with invisible tides, its surface restless as water beneath an unseen wind. This is the true portrait of the void, not a clean erasure, but a living background. Even where nothing seems to exist, quantum fields fill every point. They are the scaffolding of reality, a silent ocean extending without boundary. These fields cannot stay perfectly still. They fluctuate, their energy rising and falling like invisible waves. This trembling births brief sparks of matter, virtual particles flickering in and out of existence faster than any camera could see. What we call empty space is, at its smallest scales, an incessant storm done. Imagine an endless foam at the bottom of a black sea. Particles appear, annihilate, and disappear again. For a heartbeat, they borrow energy from the vacuum, then pay it back as they dissolve. This quantum foam is the ground note of reality, the texture underlying everything. It can bend the paths of light, shift the orbits of electrons, and pull on metal plates without a single atom between them. The void leaves fingerprints everywhere, yet physicists speak of two kinds of nothing. One is the vacuum we know, filled with energy, alive with fluctuations. The other is true vacuum, a deeper nothingness whose properties may be fundamentally different. Our universe may be perched on a plateau of false stability, like a ball resting in a shallow hollow. If there is a deeper valley hidden beyond, a single nudge could push the cosmos into it. That event, false vacuum decay, would begin as a tiny bubble of new space, expanding at nearly the speed of light, rewriting every law of physics as it swept outward. No warning, no defense. The universe as we know it would dissolve. Physicists run the numbers and find comfort in vast timescales longer than the age of stars, longer than any human reckoning of time. But the possibility remains written into the equations. The void is not guaranteed to stay the same. It may not be a quiet end, but a sudden phase change, the most violent event conceivable, happening in complete silence, across the great canvas of cosmic time. Even the giants of creation fade. Black holes, once thought eternal, slowly leak their mass through Hawking radiation. Each particle they emit carries away a trace of the hole's energy, shrinking it until, after trillions upon trillions of years, it evaporates into the background. With every black hole gone, the universe loses its last anchors of structure. What remains is a bath of low-energy photons and faint particles, stretched thin across a space still swelling outward. This is heat death, the cold, dark, endless expansion foreseen in the 19th century and revived by modern cosmology. But the story may not end there. The force driving cosmic acceleration, dark energy, is still a mystery. It may remain steady, leading to a smooth, empty infinity, or it may change. If its pressure increases over time, the expansion will not just continue but accelerate catastrophically. Galaxies would first drift apart. Stars would unbind from galaxies. Planets would lose their orbits, molecules, their bonds, atoms, their structure. In the final instance, even the smallest scales of matter would be torn apart, a universe undone from the inside out. This scenario is known as the Big Rip. Not a quiet fading, but a crescendo of destruction as the fabric of space accelerates beyond every limit. Other visions offer strange reprieves. Some theorists imagine the void as unstable but fertile, fluctuations capable of spawning new universes, each with its own constants and laws. Others see hints of a holographic order. Information, they argue, cannot be truly destroyed. Even when matter and radiation are gone, the void may encode the memory of everything that ever existed, smeared across the horizon of space itself. If so, then emptiness is not erasure, but storage. A silent ledger beyond comprehension. Picture the void as an endless sheet of black glass. Beneath its surface are inscriptions written in a language of pure geometry, patterns too subtle for light to reveal. These may be the holographic imprints of past universes or the seeds of universes yet unborn. The vacuum could be both a tomb and a nursery, an archive and a cradle, depending on how we look, yet the mainstream view remains sober. The simplest projection is the cold fade out, galaxies lost beyond sight, stars extinguished, black holes evaporated, and only the lowest tenergy state left to fill the cosmos. A place without contrast, without gradients, without time as we understand it, the ultimate equilibrium where nothing changes because nothing can. In that vision, the void wins, not by violence, but by attrition, draining the universe of difference until it becomes indistinguishable from nothing at all and still. The numbers are uncertain. We do not know the true equation of dark energy. We do not know if vacuum decay is real or only a mathematical specter. We do not know whether information is preserved or lost when the last black hole fades. Every theory is a map sketched over a darkness we have never walked. In the closing image, the camera drifts over an infinite plane of darkness. Yet that darkness shimmers faintly as if alive with unseen currents. One ripple rises, then another, hinting at movement beneath the stillness. They could be echoes. They could be seeds. They could be nothing at all. Inside the void, reality becomes its own question. It cannot hold still. It cannot remain truly empty. The deeper we look, the more it moves, whispering its own paradox that even in nothing, something waits. If emptiness holds a memory, it may also hold a future. In the deepest silence, new laws may already be forming, unseen, unmeasured, waiting for a universe to bloom again. Darkness folds outward, and the screen drifts with it. No stars remain to guide the eye, no galaxies to anchor perspective. Only a vast suspension, a place where time itself seems to hesitate. This is the edge of existence, the imagined horizon where the universe becomes its own absence. Within this expanse, the human story flickers like a candle, born from hydrogen and gravity, sustained by the fusion of stars. Our atoms have always been borrowed. Now those stars are gone, and yet their memory persists in us. In contemplating the void, we are also contemplating ourselves. Fear arrives first. To imagine nothingness is to imagine the end of every bond, every narrative, every memory. We are a species whose survival depended on pattern and anticipation, and the void erases both. Yet fascination follows close behind. The idea of the void draws scientists, philosophers, and poets as if it were a dark mirror. It offers a glimpse of what reality is when stripped of ornament, a test of whether being itself can vanish. Even in a dying universe, information whispers. Quantum theory suggests that information cannot be truly destroyed, that it may survive in transformed states, coded at boundaries or woven into the geometry of space-time itself. If so, then patterns outlast their material hosts. Our bodies and worlds may fade, but the fundamental imprint of what we were could linger as subtle correlations in a cosmic background. In this sense, the void becomes less a grave than an archive. The narration glides across the idea of rebirth. In some cosmologies, the vacuum is unstable and fertile, capable of quantum fluctuations large enough to ignite new inflations, miniature bangs budding from a previous silence. Each bubble could spawn a universe with its own constants and fields, an entire cosmos folded inside a fluctuation. The void, far from inert, becomes a field of seeds. Its quiet hiding an infinite orchard dot. Imagine the end of all matter and energy. Then imagine a single fluctuation, a ripple rising in the emptiness. If it crosses a critical threshold, it inflates, expanding faster than light, cooling and condensing into particles, stars, and galaxies. In this picture, our universe may be just one blossom in a chain of ephemeral blooms, each born from the decay of the last. The void, then, is not the conclusion but the common soil of all possible worlds. Yet another line of thought holds that consciousness itself may be a transient pattern, dependent on complexity, which the void destroys. If information survives only as raw bits with no substrate to compute upon, there may be no awareness left to interpret it. The universe could retain the text but lose the reader. And so the question arises, does the void itself know what it contains? Or is it truly blind, a storage without witness? In the far reaches of physics, some imagine that space-time itself is emergent, a collective behavior of something deeper. If that deeper substrate remains when space dissolves, then perhaps even the void is not fundamental. It could be a phase, like water freezing into ice, with another form waiting beyond our ability to imagine. Such speculation does not end the mystery. It multiplies it. The film lingers on a single image, a human silhouette standing against an infinite black horizon. This is symbolic, for by the time such a horizon exists, no human will remain. And yet the image captures our predicament. We are creatures evolved to measure seasons, to tell stories, to look up at night skies filled with reference points. Now we contemplate a sky without stars, a time without markers. It is an act of imagination that carries us far beyond our own lifespans, a testament to the reach of curiosity in this deep future. The cosmic background cools toward absolute zero. No chemistry operates. No gradients remain to drive motion. The last black hole has evaporated into faint radiation. And yet quantum fields persist, murmuring in their fluctuations, holding on to the possibility of difference. They are the last whispers from the edge of existence, not voices, but tremors like wind over invisible grass. We are left with a paradox. To be conscious is to sense difference, but at the final horizon, difference is gone. To be alive is to metabolize energy, but energy gradients have vanished. Does awareness fade with the gradients, or does it find another footing? This question hovers like an unresolved chord at the end of a symphony. The narration slows. The camera retreats from the imagined void, pulling back without end. Each frame loses reference points until there is no up, no down, no light, no sound. Only the shimmer of quantum fields remains, faint and immeasurable. It is not clear if the camera is moving or if space itself is moving around it. The void may be the ultimate limit of knowledge. It may also be the place where new physics begins, where the rules we know give way to something subtler. Between these possibilities, our questions remain suspended. Like the last stars before they go dark, if the universe becomes a perfect void, does it finally end, or does it begin again, silent and unseen? The question drifts without anchor, echoing across an emptiness that may yet be full of beginnings.